In this next video, we're going to look at some more trigonometric equations. Here we are still solving trigonometric equations with the difference that now we will use more of the identities. So things like our half angle, double angle, maybe sums and differences, more powers, and things like that. So in our first example, we want to solve 2 sine of 2 theta minus 3 sine of theta equaling 0. And we want to solve this in the interval from 0 to 720 degrees. And if necessary, we want to round the answers to 1 decimal place, because sometimes with degrees we're not going to get exact answers. Okay. So in this case, the reason this one is not a basic trig equation is because I have both a double angle and a single angle in my equation. And so the first thing I'm going to want to do is rewrite this so that I'm only in terms of theta. Or, if possible, write it so that I'm only in terms of 2 theta. So in this case, we can see that sine of 2 theta is 2 sine theta cosine theta from our double angle formula. And so we get that 4 sine theta cosine theta minus 3 sine theta is equal to 0. Now here, again, because I have both sines and cosines in my function, I can factor this and try and separate these into 2 separate equations. Here I have sine theta in both terms, so I'm going to factor that out. So sine theta can equal 0, or 4 cosine theta minus 3 equals 0, and I'm going to isolate these trig functions and take the inverse trig values. So on the one side we get sine theta equals 0, or theta will equal the inverse sine of 0. And on the other we get that cosine theta is equal to 3 over 4, or theta equals the inverse cosine of 3/4. So now we want to find the reference angles in the first revolution for our inverse trig functions, and then we can go about finding all of the solutions. For the cosine, you may need to use a calculator to get that, and again, round to 1 decimal place where necessary. So for the sine, we get 0 and 180 degrees, and for the cosine, we get 41.4 and 318.6 degrees. Now we want to find all of the other values, all the other coterminal angles that are also within that interval from 0 to 720 degrees. So now we'll just multiply, we'll add 360 degrees to each of our reference angles until we fall outside of that. And so we can see that theta equals 0 degrees, 41.4 degrees, 318.6 degrees, 360 degrees, 401.4 degrees, and 678.6 degrees are all of our values between 0 and 720 that will satisfy this equation. In our next example, we're going to look at 2 cosine of 3 theta equaling 1. Now this almost looks like one of our basic equations where we just have a trig function equaling some number and maybe some coefficients. But again, the difference here is we are looking at a multiple angle. So it's no longer just cosine of theta. That 3 theta changes some of what we're going to do. So we want to solve this equation in the interval from 0 to 2 pi. And again, we'll start just like all of our other equations. We'll start by isolating the trig function. So cosine of 3 theta will equal a half. And then we're going to take the inverse trig function. So even though it's not just a theta there, we're still going to solve for that angle, and the angle in this case is 3 theta. So letting 3 theta equal the inverse cosine of a half, we're actually going to solve that. So we know that cosine will be a half at pi over 3 and every multiple of that, and 5 pi over 3 and every coterminal angle of that. So 3 theta will give us those values. And we want to write it this way because now when we try to solve for theta, we're essentially just going to divide out by the coefficient. So if 3 of our angle thetas are these values, dividing out by 3 will give us our angle theta. So we can see that theta will equal pi over 9 plus 2n pi over 3, and 5 pi over 9 plus 2n pi over 3. Now, if we were looking for all solutions, we'd be done. In this case, again, we want the values that are between 0 and 2 pi. So here, we're going to look at our n values, plug in, and only list the ones that are between 0 and 2 pi. So theta will equal pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, and 13 pi over 9, and 17 pi over 9. Okay. And again, depending on what our interval is, this may change, but you'll want to find all of the values first and then limit it to whatever the interval is. In our next example, we want to solve tangent of theta over 4 plus square root of 3 equaling 0 in the interval from negative 4 pi to 4 pi. So again, here we're looking at in this case, a minimal angle. It's not multiple, where it's theta over 4. So we're again going to start by isolating the trig function and then taking the inverse and then solving. So theta over 4 will equal 2 pi over 3 plus n pi, and now we're going to multiply by 4 to get that value for theta. So this gives us all of the solutions. Now we just want the ones within the interval from negative 4 pi to 4 pi. So evaluating values of n, we see that theta will equal 4 pi over 3, the negative of that, or 8 pi over 3. In our last example, we want to solve 4 sine of 2 theta cosine of 2 theta plus 2 sine of 2 theta minus 2 cosine of 2 theta minus 1 equaling 0. And that's a mouthful. It's a long problem. We have multiple trig functions and we've got some multiple angles. So again, we want to start by isolating things. Here again, we can start by factoring things out and then rewriting our equation. So separating these, we can see that 2 sine of 2 theta will equal 1, or 2 cosine of 2 theta will equal negative 1. So solving the 2 sine of 2 theta equals 1, we'll isolate the trig function and take the inverse. And we're going to do the same thing for the 2 cosine of 2 theta equaling negative 1. So here are the values for 2 theta within the first revolution of the unit circle. Again, we need to first find all of the coterminal angles, and then we can go through and divide out by the 2. So theta will equal the 15 degrees plus 180n, 75 degrees plus 180n, 60 degrees plus 180n, and 120 degrees plus 180n. And so now we can go through and solve for our different values. So now that I have all of the solutions, we want the ones that are just between 0 degrees and 720 degrees. So theta will equal 15 degrees, 60 degrees, 75 degrees, 120 degrees, 195 degrees, 255 degrees, 240 degrees, 300 degrees, 375 degrees, 420 degrees, 435 degrees, 480 degrees, 555 degrees, 600 degrees, 615 degrees, and 660 degrees. Okay, so as you can see, some of your problems will give you a lot more angles even though you're looking at a restricted interval. Some may not. All of them you're going to want to follow the same steps. So isolate your trig function, take the inverse, find the reference angle, and then find all of the solutions you're looking for.